All right. I think we're live. Yep, we're live. All righty. We're going to try something a little bit different tonight. So, I have a console application in .NET. I built this last night, the night before. Kind of as a little bit of an exercise in integrating tooling from an API for large language models. So I had Grok do the heavy lifting for me because I'm lazy, and had it spit out a nice little basic HTTP client that'll talk to Grok API, which is built against the OpenAI completion spec. So technically, I could just make a generic one. Yes, for all the nerdy developers out there, I'm not going for the perfect code. I'm going for a simple demo, just to kind of showcase some of the neat things you can do without needing any custom NuGet packages or libraries to set this up. So, basically just some helper classes to help serialize the inputs and outputs of the REST calls, and probably the meat and potatoes. Well, of note, there's also a session management piece here that just handles the tool calling itself. And then of note, probably the most interesting bit here is the tools themselves. Not because they're anything fancy, but because they're actually really simple utilities. For my example, basically, I'm just wrapping file I/O calls. So read file, create file, update file, get files with extension, get all files in a directory. I'm passing the tool configurations to Grok, telling it what parameters it takes, and then the tool executor will expect that tool name and then in turn call whichever function and log it, to the console so we can watch it work. And then each of these functions, if we look at them, right, create file, read file, get file, basically Grok's just going to say, hey, list directory, and then log and return is going to call list directory. And list directory is going to call, you guessed it, directory exists, and then enumerate files in system directory. So we get all the files back. Those then get passed back to Grok, and then it decides, do I need to call more tools? And then it just basically goes round and round through all these different options, iterating over the different tools, building what it wants. So multiple LLM calls in the process. My executable is the thing that's actually touching my system. It's just I'm letting the LLM tell it what to do. So I'm going to kick this off because the real magic is actually just letting it run. So we create the client, I run it against a particular folder, and then I give it this rather obtuse and not well-defined prompt of design a system .NET-based Blazor application, kind of the way Wikipedia is structured. So we'll see what it'll do. And then after it designs the system, then I tell it, build it, and I give it the list of the tools, all new line separated, and what they do. So it knows it has the tools. The API also takes them in the request, but I wanted to make sure it, the LLM knows specifically, like, use these to figure out how to do this. So I'm going to let this run, and then we can watch this kind of do the bidding in real time here. And then while that's happening, I'm going to change this. Now that we've seen it design the system, it's going to actually start making tool calls to the file system and start creating the individual files one by one, point by point. I don't have it putting that content out into the browser just because that, or into the console, just because that'll kind of make it harder to watch the tool call flow of, now that I handed it this design, or I should say it designed it itself, and then it got a list of files in the tree, and then it's looking to see if there's existing files, and now it's starting to write. And those actually all happen really fast because it gives multiple tool calls. You can see it gave the content and starts writing the files. We can actually see them pop in over here. It happened pretty quickly, and now it's finished. So I can come over here and I can see program.cs. There's some artifacts, like this should be an angle bracket, as you know, because I'm not doing any sort of special qualifications. But I don't know. I think it did a pretty good job of stubbing out an initial application with settings, assuming you want a database, some services that handle Markdown, which is a hallmark of Wiki styling. Nothing too crazy. A general like content revision type functions, so on and so forth. For giving it basically no input other than make something that's .NET based, that's sort of Wikipedia style. I think it created a handful of useful things. If I gave it directives, like specific instructions, like create this file, create this class, create this, do it this way, and did this incrementally and built kind of a model and a pattern to it, I'm pretty sure I would be able to get the template for that, the spec, if you will. OpenAI started to call them specs now, up to a point where, you know, it might start to compete with templates in Visual Studio. I still feel like developers would prefer to actually just build like the starting of a project themselves. If the LLM can write the code all the way from end to end, and it builds and it compiles and it works, that's a cool science project. But I mean, at the end of the day, when that bug rolls in 6 months from now, are you really going to just point the model at it and say fix it? That feels kind of risky to me. Now, with the right structure and guardrails and metadata and engineering around how AI should like work within that project, I think you could get there. But it's not a moonshot like what we have right now in a lot of the craziness that's on social media and whatnot. You need to kind of like design how this is going to be used. Like case in point, these little artifacts here and there, like you're going to spend all day going back and forth with the model trying to get it to get all this right, or you're just going to write it by hand and get it right, the first time. There's a balance for sure. But anyways, thanks for watching. Just wanted to show a little science experiment I did the other night.